Okay, hello everybody. This is the recorded part of the session to study math functions, and during that session we studied how to use the math functions to, as an example, scale the sensor input. The sensor input, in fact, when we have a sensor, the sensor itself transmits some electrical signal in voltage or current. For example, in this curve, the voltage is between 0 and 10 volts. That 0 to 10 volt, in fact, represent 100 to 500 degrees centigrade. The sensor measures that temperature, generates some voltage between 0 and 10 volt, and transmit that to the PLC. The PLC input card, in fact, the A to D part, analog to digital converter part of the analog input card, convert that, or let's say read that voltage 0 to 10 volt and generate a binary value between 0 to 2706,048 as an integer number. And our task is to read this value, this number, and generate or scale that to the physical range, 100 to 500 degrees. The formula, we studied that the formula that can do this task is, in fact, here. This is the main formula. The scale value, I mean the physical value, the temperature, is equal to the input value multiplied by the slope plus the offset. The slope of this curve and the offset of that. The slope can itself be calculated by this formula and the offset by this one. So our task is to build a program to implement these formulas. We studied the program. At the beginning we should assign the parameters, the initial parameters to that, and then calculate using these instructions to calculate the slope, scale max minus scale mean at this one, input max minus input mean at this part, and dividing them. Also for the offset, calculate this multiplication and then subtract that from the scale mean at this one to get the offset. And finally, if we have this slope and offset, we can calculate the scale value. First calculate this part, input multiplied by the slope, and then at this instruction add that to the offset value to get the scale value. This is one way to use individual, let's say, core math functions. But the other way was to use calculate. But the calculate, we can do some more complex calculation, and we saw that for our example, again, we need these assignments, but also then we can calculate the slope just by one block. All the parameters, scale max, scale mean, input maximum mean, is given to that, and the whole program, in fact, the whole formula is implemented, can be implemented directly here. This, in fact, is a replacement of this part of the program, the whole part of this. Also, to replace this one with the calculate, we have this calculate, okay, with the formula according to that. And finally this one. These are the two ways, and we also will study another way to just for normalizing, for scaling in the next session. But for this is just as an example for the math functions. So there are two ways. We are going to implement both of them, and then for the HMI, this is the HMI that we are going to build. It has two screens. In the root screen, here we have a bar that shows the analog input value, that's 0 to 27,648, and the scale temperature calculated by the math functions, those individual math functions, and also scale temperature by calculation. For these math functions, also we have a trend. If you double click on this one, or sorry, in the screen, you click on that or touch that, then a new screen appears. In that screen, we have the curve or the trend. And we are going to also build this one, and also it has a back button to return to the main screen. So this is the whole program and the HMI that we are going to build today in our PLC and HMI system. Okay. Similar to the previous sessions, to speed up the building the programs, I created a new project and defined and add the PLC and HMI to that, and now we have a blank file to start program. Okay, the program that we are going to build is this one, so let's have a look again to that. Start from here. Here we need 4 move functions that the parameters are given to them. These numbers can be any number. We are not. It's not necessarily to be these numbers, but we can use the same. So let's build this. So at the beginning we need move. Okay, where's the move? If you look at here, we have already used timer and counter. We have also comparator that we will use in the next session. Math functions and move operators that we need in this. For the move, there are lots of instructions. The one that we need is this one. Okay, just one move here, and we're going to this 500 to give to assign that to NW. I don't know if I'm not sure what was the number. 0. So MW0. Okay, please notice that MW in fact is a okay, this is a memory, but when we have a word, it means that the PLC assigned 2 bytes to that, so we should not use MW1 because 1 is part of this one. MW0 means byte number 0 and byte number 1. If you address byte number 1, there would be some conflict, so do not use that. And this is scaled max. Okay. Let me add in the same network. Okay. So a branch, and then another move here, and then another branch, another move. We need 4 move functions, so another branch, and this one, just one branch. This one, move, double click. Okay, we don't need this one, so let me delete this. Okay, so then 100. 27,648 if I don't make a mistake, and here is 0. Okay, and then the word numbers that we have here are MW160, MW22, and 13. 160, 22, and 13. MW160, MW, I forgot, 13, is it 13? Oh, 22 and 13. So MW22, MW22, and MW13. Okay, and this is scaled. You may prefer to call that temperature max, temperature mean. That's much better than scale max and scale mean, but it has more. It is more meaningful. Input max. Oh, sorry, I made a mistake. MW22. The tag. So input max, and this is input mean. Okay. Okay, this is the first part. The second page is, let's say in the next network we are going to build this. We need to subtraction and then a division. Okay, so and the scale max scale mean, input max input mean, and then slope numerator denominator, and then calculate the slope. Okay, so this is something that we need. I add that to a new network. So here we need subtract first. In the math function, okay, under this math function, you can see all the basic and also calculate. So subtract, one subtract here, one more here, and finally we need a division. Again, another branch, and this type division. Okay. Okay. The input to this one must be scaled max. Okay, you see that using tag make it very simple. We don't need to memorize them. Scaled mean. Okay, so subtract these. Also input max, input mean. Okay. The output, in fact, let's use the same address to make it simple to track. MD4 and MD120. Okay, what's the difference between MD and MW? W is a word, so it uses 2 bytes, but MD is a double word, and so it uses 4 bytes. But the most important is that if your number is going to be a real number, it should be double, so it needs 4 bytes. So we use MD. And why it should be real? Of course, these are integers, so the subtraction are integers, so it is possible to have MW also, MW, but but because later we're going to divide them and make the slope, and the slope is definitely a real number, so I start from here and assume and assign real number even in these two. It is possible. It is possible here to have MW4 and MW120. That's fine, and you can use MW4 and MW120 here. But from this point, it should be real. So, just for simplicity, I only assign integer numbers or W word memory to the initial parameters. That for all others I use MD, just to make it simple. But of course, the cost is that we use more memory. But in this simple program, we are not worried about. We don't need to be worried about the memory. But in a very large scale programs, yes, we should also take care of that. But generally, it's not that big issue. So MD4, MD120, and later MD130. So that's MD4. You see, MD4 is good because we use MW0. MW0 means byte number 0 and 1. So this we can start from MD2, but I start from MD4. So this the tag I will assign MD120 later and 130. MD130. Okay. Okay. Yeah. A data type. I will let you know what's that. Okay. Just a moment. But here, let me just assign some number. This is the slope numerator. This is slope denominator, denominator, sorry, denominator. I hope I don't make a mistake. Okay. And then, okay, let's assign these two values to them. Okay, here, the output, you can assign which type of output, automatic or no. I assign real number to them, so these are real numbers. And you see that two small square appears here. It's because this calculation is going to be based on real number. I select real. Why real? Because I assume that the output is going to be real. But the two inputs are not real. It automatically converts them to real. So you see, it automatically, and this shows that, okay, this is a conversion. This is a kind of implicit conversion from integer to real. Okay, so automatically the program understand that and convert that. Again, here you see, right now it is automatic. It assumes that these all of them are integer, and these two are integer, and since this is MD, so it needs a converter from integer to double word. Okay, but as I select these to be real, and so the output is real right now, the output is not anymore the output of the calculation is not anymore integer, so it doesn't need that conversion, but it needs to conversion from integer to real. Okay, and then let me assign these division for, so slope okay, yeah, the reason that these the numerator and denominator does not appear is because right now it is integer, and these are the only integer numbers that we have. They are not. So something we should do is this: either change this to real, okay, and then here, yeah, since it is real, so it assumes that the inputs are going to be real, and so slope numerator or and the slope denominator, or you can simply click on this, give these addresses. So MD120. Yep. So in fact, the type of the inputs and outputs are important. If it is real, it assumes that everything is going to be real. And if you give a real number, it doesn't need any conversion. But if you give an integer number, it needs a conversion. And the output is going to be, okay, MD130. This time it accepts. Why? Because it is real, and MD is the type that we can, the memory that we can assign to real numbers. Okay, so slope. Okay, that's this part. Okay, the next part is this. We're going to build this one, simple multiplication of input, mean, and slope, and then save that as the second term, and then subtract that from the first term, scaled mean, and so we need a multiplication and subtraction. So let's add a multiplication, this one, and also a new branch, and it was subtraction, yes. Yeah. So for the multiplication, scaled, what was that? Scaled mean and slope. So scaled mean, okay, and slope. Okay, automatically, since this is a real number, it converts this to real, because all of them should be in the same type. So it automatically, it is automatically convert that to real. You can also select that to be real, but it also automatically convert that to real. And so this is what is the address for this one? MD140. MD140. This is offset second term, and then here subtracting scaled max from offset second term. Okay, let's see. Oh, sorry, scaled me. It should be scaled me. Scaled me. Yeah. Okay. And offset. The address that we use for offset is MD110. So MD110. And you see, automatically, since one of the inputs is real, so it assumes that the whole calculation is based on real, and so it automatically assume that the calculation is real, and so select the real. So MD110 is it? Yeah, and then this is offset. Okay. And the last part is to use the slope, the offset, and the analog input to calculate the scaled value. We need a multiplication and addition for these two parts. Okay, so let's add them to the program in a new network. So we need a multiplication here, and also branch with addition. Okay, for the multiplication, something that it's analog input value and the slope. Okay, regarding the analog input value, it's input word 64. Input word, so the analog input is an integer value between 0 and 27,648. So it is an integer number, but how we reach to that the input, the address of that is 64. Okay, to find out where is that, okay, look at the device configuration here. Okay, click on that, and then if you see here, when you have this window, the PLC, here is another part that pop-ups device overview, and here you see that the PLC one, this some information. The information that right now we need is the address for the analog input, the digital input, digital output, analog input. Okay, the analog input here, if you drag to not that much, slide to, if you slide to right, you can see that some information regarding the slot that is not important for us because this device does not have any external device, but if you, and the slot number is internal numbers, so it's not important. The address is here, this is important. 64 to 67, so 64, 65, 66, 67, it uses 4 bytes, assign 4 bytes to 2 analog inputs. In fact, 64 and 65 are for analog input number 1, and 66 and 67 for analog input number 2. This is how we can understand the addresses for the analog inputs. Of course, you can change that, and in the Motrol trainer, the manuals, they change these to 100. I think 64 to 100, but I'm not going to change that. I use the original addresses. So 64 for the analog input number 1, and I know that 64 and 65 are the bytes of that. So let's go to the program. In this program, we need only one of them. So of course we can use the other one for the calculation. That's a good practice. So here I need analog, input word Okay, input word 64. Okay, and call that, let me call that analog input 1. Okay, and here the slope. Okay, so this is the scale value term 2, or let's say term 1. Of course, that's not correct. Term 1. This is the term 1. So scale value term 1. The number is, and the number is important, is MD170. You can use any others, but MD170. But please take care of conflict with the other addresses. As I mentioned, if you have, for example, MD110, it means that 110, byte number 110, 11, 12, and 13 are reserved for MD110. Do not address either any of them. But 170, that's good. So this is scaled value second term. Oh, first term, or term, first term. And then here you can use this scale value first term together with the offset value to find the scale. And the scale value is MD150. So this is offset. What's happened? We should have that offset. Okay. Offset here. And MD150. Okay, get back to that to see what's wrong with that. But here, let me scale value. Okay, good. And here automatically real. And here the data word of the, yeah, okay. Let me convert this to real. Okay. And yeah. Why it doesn't accept automatic change conversion? I think it will convert that later during the running. Okay, to fix this problem, just once right click and rewire tag, and then under this data type, once select double word, and then again integer, and change. Automatically that converter appears here, and then everything will be fine. Okay, so to solve this problem, right click on the tag and then rewire tag. When you open the rewire tag, select this data type, double word, and then again return to the integer, because the integer is the one that we want to change, and then that converter appears automatically. Okay, so now we have the scale value based on math functions, but we also want to do that similarly with the calculate. So also let's prepare this part of the program and then work on the HMI part. For that calculate also we need this part that we have already done, so we don't need to do anything then, but let's add a calculate to calculate this slope directly and then this one, and then this one. So we need 3 calculate functions. Let me, in a new network, add calculate is also here under the math function. So one calculate here, and one more here, and one more here. Okay. The first one is to calculate the slope. Okay, but for the slope we need, here you see that we need 4 inputs. We need 4 inputs. Okay, to add new inputs you have this icon here. Let me show you here. Okay, here if you click this one, new inputs appear. The first one is going to be scaled max, scaled mean, input max, and input mean. Okay, for the output we use MD230, MD230 and here you see that the type of the variable is going to be real. So also let me select this to be real. Okay, you see automatically these converters appear, and MD, forget 230, MD230, MD230, which in fact is the slope based on calculation. So slope based on calculate, just another tag for that. So let me here slope calculate. Okay, but regarding the in fact the actual value, the formula, if you, let me show you again, if you double click on this output, then the formula window pop-ups, and then you can prepare the formula. The formula is based on the inputs, not based on the variables, based on these inputs here. But we know that the input 1 is a scaled max, scaled mean, input max, input mean, and the function that we are going to implement is this scaled max minus scaled mean divided. So input 1 minus input 2 divided by input 3 minus input 4. This is the formula that you see here. So simply input 1 minus input 2 divided by input 3 minus input 4. Okay, that's all. That's all. Then for the second one, this one, offset, scale, we need again one more. The first input is scale, the slope calc, the slope that we just calculated, this one. Then input, minimum input, and the scale. So let's have these. We need one more. This should be slope based on calculation. This is input mean, and this is scale. Okay. The output address is MD210. So MD210, and this in fact is the slope based on calculation. Just to distinguish them, we add them, but the value is the same. The value is the same as this. Oh, sorry, the offset. Sorry, the offset. The offset. It is the same as the offset that we calculate based on the math functions. I mean that individual math functions. But just to distinguish them, we add this calc at the end to distinguish them. And okay, the formula is this. The formula is scale mean minus input mean multiplied by slope. So input 3 scale mean input 3 minus input 2 multiplied by input 1. So input 3 minus input 2 multiplied by input 1. And here for the last one, something that we need is analog input, also slope and offset based on calculation, and the final is this value 250 for the scaled value calc. So let me start from this one, MB 250 as the scaled value based on calculation function, and here we need 3, the slope based on calculation. Oh, sorry, no, just a moment. This should be input. Input word 64. Okay, and here is slope, and here is the offset. The order is not important. You can change these order, but you should take care of that during the formula also, implementing the formula. So the formula that we have here is input value multiplied by the slope plus offset. So it means that input 1 multiplied by input 2 plus input 3. Okay, this is the function. So double click on these. Input 1 minus, input 1 multiplied by, oh, okay, yeah, the reason is this, just a moment. This should be real. Okay, and here it is real, yeah. So, input 1 multiplied by input 2 plus input 3. That's all. Okay. Yeah, it is real. Yeah, that's all. This is the program. So the program is ready. Let's slide it up, and then let's, okay, no error. And then let's download that to the PLC. Okay, here it asks which PLC, search for that, for compatible types. This is the PLC, yeah, and then load. Okay, again it asks whether to put that in the stop mode, reset the module. So yes, change that to the stop mode. It reset everything because regarding the IP, regarding the everything, and then start that. Yes. Okay. So the program is over. The next part is to prepare the HMI and then test that. Okay. Let's have a look to the HMI. For the HMI, we want to use the bar and also the trend. So it's not a very complex HMI from the, let's say it doesn't have that much objects, but we are going to study these bar and trend objects. So let's start the HMI and the screen, and the router screen. Okay, this is the router screen. Okay, here we have the bar. The bar is here. We need 3 of that. So simply 1, 2 and 3. Okay, we can have some text for each of them. The title, you can also add title here, but I add as a text. So input value. Okay, simply. Also another one for this one, temperature math, just to indicate that it's based on the math. Of course, calculation is also math. I mean that simple math, but this is temperature by calculation. Okay. Also, we need a tab. It's a button to go to this. By clicking on that, go to the trend curve. Where's the trend curve? Okay, add a new screen. Double click here, and then the screen here, and the curve is you can find the curve under this control part. So click here, and then have one. Let me reduce the size. Okay, and then we can adjust the size of this. Okay. Also, we need a button here to return to the main screen. So just back. Okay. These are the objects, all the objects that we need. But okay, to assign properties, we need to assign values to them. Okay, for this one, let me increase the size a little bit more. Okay, so we can do here. Okay, for this one, okay, double click on that, or if it doesn't work, just right click and click on these properties. Okay, then the first appears. Okay, the color, and like that, borders or many other parameters that can be changed, that we will look at that later. Okay, layout, text, limits, and many others. Okay, you may have some limits on that and like that. Okay, so, and also the general. The general in fact is where you can assign the maximum and minimum to that. For our case, the maximum is 27,000 for the input value is 27,600 something. So let's assume that this is 3,000, the maximum value. Or maybe we can use the same. Let me use, it was, I forgot. Oh, no, this is not correct. It should be 27,000. Okay, 27,648. Okay, so 27,648, the maximum and the minimum values. What is the tag? Here you can assign the tag for this. So the value of that tag is used to change the position of that. So it is analog input number 1. Analog input number 1. You can change many parameters here. For example, the color, whether to be blue or any other. Let's keep it blue, and many others. I'm not going to go through all these details. You can play with that to find more properties and change them. For this one, this is a scale temperature. The temperature is changed between 100 and 500. So let me change the range between 0 and 500. And this one also 0 to 500 instead of the 100 to 500, 0 to 500. Let's see what will happen. And then this tag for this one is the scaled value calculate. The tag for this second one is scaled value. Scaled value. Okay, so this bar change based on the scale value, this one based on the scale value calc, and this based on the input value. Then we have a trend button here, and when this trend button, when we click on that, under the event, when we click on that, something that we expect is that the screen for the trend opens. So under the screen, active the screen. Which is screen? Screen number 1. Okay, that's all. And then let's go to the screen number 1. You can change the color or any other part that you prefer. For the screen number 1, there are two parts. Let's first, don't forget to assign the event for this one, for this back. When we click on that, then we want to activate the previous screen. So when you click on this, it returns to the previous. But regarding this curve, this trend, there are many parameters that can be assigned to that. Let's look at some of them. Okay. First, you can under the train, the first one, under the train, you can assign the variables that you want to draw the plot, the change on them. So here, let me add, for example, when you click on this one, then source setting. Under the source setting, let's have this input, analog input value. Okay, the input. Okay, every 1 second it updates, or the value changes every 1 second. You may change that to 0.1 or 0.5, something like that. But generally, very fast is not necessary, because it's not difficult. It's not that. Let's say for the operator cannot even recognize any change in less than 0.1 seconds. But for saving as a historical data, yes, from that point of view, it is important. Let's change that, for example, to 0.5. Okay, so every second, 2 data change here. You can change the color of that. Let me change this color also to, for example, I don't know, red, for example, and some other parameters. We'll back to that. We have not yet finished with these, but another trend. The other, and what is the name of that? It is analog. You can assign any number. It's not necessarily the same as the tag, but let me analog. Well, let's just put that input. Okay, just input. The second curve that we want to show here is, in fact, that scale value, or scale value and scale value calc are the same. So just one of them is sufficient for our program, and again, every half a seconds. And the color, let's change this color also to, for example, blue. Okay, that's. Then how many, because this show the plot, but it's a moving plot. So as the new data generated and added to that, some data from the right side, some data from the left side leave the curve, and so all the times you have some specific number of the data points here. That specific number is given by this. So 100. It means that just 100 data is shown here. You can change that. You can say that, okay, I want to have more data numbers. let's keep it 100 later if it is necessary. We change to see that. But something that is important is this slide. It has some scale in the left and right. Which one are you going to assign to this input, and which one to the second one? Let me change this to temperature also. Okay, so let's assign this the left scale to the temperature and the right one to the input value. So here the input value, the value that you see in this scale, this vertical scale, is for the input value, I mean the analog input, and the left is the temperature. Okay, there are more. Then, okay, some appearance here. I think we don't need to change that regarding the border, layout, and like that. But here it is important. There are some that we need. Left value axis. Okay, so the axis in the left, okay, axis start and axis end. This is the temperature, and the temperature changes between 0 and 500, between 100 and 500. So let's have axis between 0 and 600. So a little bit larger than the axis. Okay. This is regarding the increments and the marks that you can see here. For example, if I remove the label, oh, sorry. Okay. Remove the label from the left, so it used the labels on the right, and this is the reason that you see here it's changed. But we can change the label number. Okay, sorry, the mark number. Sorry. Okay. Yeah, this the mark, and so you see the difference between them increases. How many marks? How many numbers for that? And also, I changed these to 100. Okay, so every 100, just 100, 200, 300, and like this. To the right side, again, this is the integer number. The input number is between 0 to 27,000 and something. So I changed that to 0 to 30,000. Okay, and I don't need this, but I don't need too many labels here. Let's keep it. What is this label length? Label length means that the length of this number here. For the left side, the numbers are between 0 and 600, so just 3 digits is sufficient. But in the right side, it is 0 to 30,000, and 30,000 has 5 digits. So let me increase that to 5. Okay, now you see that it is 30,000. If you use less than that, since the number of the available digits is less than the number of the required one, so it shows as sharp. So increase that to at least 5. Okay, let's don't change anything else, and then we will let's download that and then see if it is necessary to do anything else. So yeah, let's compile that. No error. Download that and see the result. Okay, here, no, it is also, the HMI is also connected to the Profinet, and so search on the Profinet for that. It is not connected directly to the PLC. Okay, this is load. Okay. Let me turn the camera off. Where's the camera? The other camera. Okay. And then I will explain this part, but let's first load. Okay, you see that it's loading. Okay, this is the screens. Okay, there is something wrong on that. Here you see that the range of that is not correct. Most probably didn't make it correct. Temperature cap. Okay, there's something wrong on that temperature cap. Okay, we'll look at that. But first, let me explain the setup and then go to them. Okay. The analog input, as I mentioned, is a sensor. It's going to be the output of the sensor. The sensor measures the temperature and convert that to the value 0 to 10 volt and transmit that to the PLC. Here, instead of the sensor, I use just a power supply to change the voltage between 0 and 10 volts. Okay, between 0 and 10 volt. And here you see that when I change that, the input value changes and also the temperature changes. Why this is not changed? We should look at that. Maybe there is something wrong in the calculation, but this is how it works. Okay, so let's first, there are some, we need to improve the performance of that on this screen at least. Here you see that there's not any mark here. Also there are lots of marks here, and also this is more than the actual value, so a bit more than 500. It shouldn't be more than 500 because the temperature calculation should be less than that. So let's see the program and also the HMI to find out why this happens. First, okay, we can also see the trend later, but let's work at this part. For this, okay. Okay, here under the scale there's a option auto scale. You can define the number of the division and mark label, but the one that we can use is auto scale. When you click on the auto scale, it automatically depends on the the range of the number and readability of them, assign some number of the divide that to some numbers. We can start with the auto scale, and then if it is necessary, change that. Similarly for this one. This one also, let me use the auto scale for this one, and similarly for this one, also auto scale. So for all of them, it is auto scale, and automatically a program select a scale for them. So I guess that for these two, let me show, for these two, it is sufficient to have auto scale, and so it assign them automatically. But there's one more, we have something wrong in this number. Let's have a look to the program and see why the number is not. Okay, first let's see the tag number we assign to this one. It is scaled value calc. It seems that it is correct. So let's have a look to the program. There might be something wrong in the program. Okay, the program, let's go online. Let's monitor that. Okay, and see why the calculated value is not correct. Okay, so the offset is 0.0144, and the offset is 100, and the slope is this value. These are seems to be correct. Let's see the previous, the other one. Also, for this one also, the offset is up almost this, but let's see the slope number. Okay, the slope is correct, yeah, the same slope, and the offset is also 100, which seems to be correct, approximately 100, and so the value of that is 179, which is correct, but here it is not. Okay. It seems there's something wrong here. Let me see. Yeah, the number is not correct, so let me just go offline. Okay, and then let's see. Yeah, it is real, that's correct. So the input 1 multiplied by input 2 plus input 3. Input 1 multiplied by input 2, analog input 1, slope calculate, plus input 3. This is also correct. Check this. Let me change this also to word, to real number if it accepts. No, it doesn't accept. Okay, to see what's the problem, it seems that this might not be a real number. It might be, let's look at the tag here. Okay, show all tags. Okay, here you see that, for example, the scaled value is real, but the scaled calc, value calc, is double word. It doesn't change automatically for some reasons, but don't worry about that. Just double click on these and go down to change the format of that real. Okay, and then again on the program, then again download that. Download that on the PLC. Okay, and then let's run it. It's of course in the run mode. Let's set that in the monitor that. Okay, here you see that the value is correct. I change the value, and yeah, it is consistent. 159, and also the same as 150, for example, 7 or 100. So they are consistent. Regarding the monitor, or let's look at the monitor. Here also we see that okay, the value changed significantly, but this is not yet. Okay, we have not yet downloaded that. Okay, we have not yet downloaded the previous ones. Okay, let me also download first and then see what's the result. I think we didn't change when we changed this. We didn't download that. We have already changed this, but we didn't download. Okay, so let me first download that and see the result, and if there are any thing wrong on that, correct that. So override. Okay, so that's good. You see, this is the integer number, and you see that better scaling. And then by changing this, okay, see the change in the range. So these are equal, and this is the input integer, and these are the values. Okay, so let's check the trends of that also. Push this trend, and you have the trend. Okay, very good. Everything is good. So, oh, sorry, I forgot to show you the. Okay, let me back. Okay, sorry, I should forget to show you. Okay, here you see that the scale, everything is good. The scale, the number of the labels, and also the scale is good. And then when I increase and decrease that input value, the voltage, the number changes, the integer number in the input, and also you can see that the temperature value also changes. Okay, good. And then let's go to the trend. This is the trend. It's not perfectly, let me see, okay, sorry. It seems that the camera is connected. Connect the camera. Okay. It's not very clearly shown here, so let me just move this a little bit closer so you can see this better, hopefully. Yeah. Not very clear, but here it seems that it's better that I camera doesn't have a zoom, so I need to move the camera. Just simply move the camera. Okay, that's good. So now you can see this is the curve. Okay, let's have a look to this. Let me change the value of the voltage a little bit, and here you can see that the curve, the temperature, and the scale value. The left side is 0 to 1600. The horizontal okay, that is okay. That's good. Okay, here you see 0 to 600. There's no more label here. We can fix this. But also from 0 to 30,000. The blue curve, here it's mentioned, the temperature. The blue is the temperature, scale value. And the input, the red one is the input, analog input. Also, there's one cursor here that you can move that. And if you want to see the value at any point, change this. See, as I change the voltage, so the input changes, the red curve, and the scale value, the blue also changes. Okay, and okay, there's a cursor here that you can move this. Just simply move this. See this vertical line. Okay. And then you can read the exact value of the variables here by this one. Okay, by this one. Okay, and you see that the curve, the new data, appears in the right side. So when I change this again, you see that the values appear here, and they move to the end. The total number of the values, the points that it's shown. We set that to 100. It was the default value is 100. We can change this range. We can change this range to more than 100. So we can change that. We do, and also we can add some more scale digits here. It has some also properties like zoom or forward, backward, or something like that. Let's just skip that. Let me see if I can fix this here. Then then fix the camera. Okay, good, the camera is fixed here. And then let's do some modification on this trend. Okay, so let's back to the screen, and then here, okay, right click and properties. Okay, we can change this data numbers, but something that I'm interested on that right now is this left axis and right axis. Auto size, can use the auto size, or no, 0 to 600, that's good. And then here increment every 100, that's good. Okay, that's good. And what about the right one? 0 to 30,000, that's good. And increment every 30,000. Yeah, every 3,000. For the left, change that to, for example, 50. Okay, let's save and see what's happening. Here you see the number, instead of just 0 and 600, also you have 300 and also some changes here. So it is possible to change them and adjust them as it is required. Okay, so let's have a look to some of the other properties that some of the parameters that we can change. There are lots of parameters, but some of them that can help us to improve the readability and the appearance. Okay, on the trend we select 100 data points. One of them is that, and you remember that the cycle time or the sample time is 0.5. So totally 50 seconds for the whole curve. But there's one parameter here that must be consistent with that, and that parameter is on the time axis. Right now, the default value for the time interval axis is 100 seconds. So this is totally 100 seconds. But according to our selection here, we have 100 points, each one 0.5. So totally 50 seconds. So it just shows half of the, I used half of the axis. So we should make them consistent. So let me change this to 50. So the whole range is 50 seconds, and the whole 100 samples can be shown here. The other one is regarding the left and right sides. Here we may need maybe we prefer to have also 100, 200, 300 labels here. To do that, here select every 100, and then in every 100 we're going to have just one increment. This is for the marks. This is for the left axis. For the right axis also, every 30,000, because it is 30,000 every 3,000, so 3,000, and also for each of them, so 1 mark. You may change that. Let me just, as a for example, use another one, for example 6,000, and then 1 mark. So you see that 0, 6,000, 12,000, something like that. So you can change this. And there are many other parameters. There are many other parameters that you can set by playing with these and change the type of the scale, the text, and like that. But let's just look at the result for these. See the result on the screen. Okay, here you see we have more labels, numbers, and here also. And also here you see that the let me increase the value a little bit. Okay, and here you see the values change. And we are going here, and the whole curve reach to the end. It just shifted as a window, moving window, shifted to left. And I just changed the voltage, playing with that to change the voltage. Okay, see, as new data appears here, the previous data is from the left, leave the track. Just changing that so you can see the results. Okay, here you see. Oops. Okay, as I mentioned, there are many other. This is beautiful to make the values, different values here and there. Okay, and so there are many other parameters that you can yourself work with that to get familiar with that.